When we draw Lewis structures, it can be a fairly straightforward approach when looking at molecules that contain predominantly elements that follow the octet rule. This will be carbon, nitrogen, oxygen, and fluorine. If we include hydrogen, which seeks only to surround itself by 2 electrons, meaning it tends to simply make one covalent bond, there is an enormous amount of molecules we can make with only these elements, including the majority of the stuff in your body. To draw these, we simply need to connect unpaired valence electrons to form covalent bonds. Let's start with something simple, like methane. If we want to draw the Lewis structure from a chemical formula, we simply write down all the atoms in the molecule with their valence electrons shown. Let's put the carbon in the middle, and the hydrogens on each of the 4 sides. Here it is quite obvious what to do. Carbon needs 4 electrons to fill its octet, and each hydrogen has 1 electron to share. So carbon makes a single covalent bond to each hydrogen atom. Now it is surrounded by 8 electrons, 2 per bond, so it has satisfied its octet. Sometimes there is a little more work to do. What about carbon dioxide? Again, let's put carbon in the middle, with the oxygens on either side. Let's take these unpaired electrons and use them to form 1 covalent bond between each atom. But then we notice that each oxygen has 1 more unpaired electron, while carbon has 2 unpaired electrons. That means we can form an additional covalent bond between carbon and each oxygen. Now each atom has an octet, carbon with 4 bonds, and each oxygen with 2 bonds and 2 lone pairs. If we are looking at a polyatomic ion, that means that 1 or more of the atoms has more or less electrons than normal. Let's try the formate ion, CHO2-. First, let's do what we normally do and draw the carbon in the center as well as the other atoms. One of carbon's electrons can form a bond to hydrogen, and then 1 more to each oxygen. Now let's work with this negative charge. That means one atom has 1 electron more than it usually does, since electrons are negatively charged. So let's add 1 to one of these oxygen atoms. Now that one has a full octet from 1 bond and 3 lone pairs. So the final electron on carbon can make 1 more bond to the other oxygen, which still has 1 unpaired electron, and we have our structure. If an atom has a positive charge, we know it will have 1 fewer electrons than its typical valence. So that means when given a formal charge, we simply add or remove 1 or more valence electrons from an atom in a way that results in the Lewis structure that makes the most sense. And now we know how to draw a variety of Lewis structures.